Hi, I'm Matt Ozalas. I'm an RF engineer at Keysight, and for the demo today I'm going to be showing you Pathwave Design 2020. Pathwave Design is basically all of our EDA tools, the entire portfolio. What we're going to do is release them and have new versions come out regularly. And the nice thing about that is we have all the tools coming out and we're able to synchronize all these different tools with their releases. So what I'm going to show you is Advanced Design System. This is released in July, so ADS 2020 will be released in July of 2019. And the demo today I'm going to show you is going to be a complex integration, and what we can do with our tools, RF Pro, is basically run an EM simulation on a piece of this. So talking to different customers around the industry, generally speaking, what we're finding is that signals and systems are more complicated, and that means that there's more integration problems. And also things are moving to higher frequencies. Moving to higher frequencies really means designers need to do more EM simulation and they need to do it more often in the design cycle. So for the ADS 2020 release, our tools are really here to help with those industry-wide problems. So I'm going to move down onto the demo here. What I have is a couple of different technologies integrated together here. I have this silicon chip. This is a transceiver, and this is through a redistribution technology. And then I have a filter chip over here. And these different technologies are then integrated into a ball grid array package. So the chip is routed through the package to the filter and out. Now, if you're doing a design of something like this, it can be quite complicated. You know, you could have hundreds of ports in the design, and if you want to do an EM simulation, it could take a really long time. But with our new tool, RF Pro, you can pull all of this design across all of the different technologies into this RF environment. And then instead of simulating the whole thing in the design cycle, what you can actually do is select pieces of the design. So I'll show you how to do that right now. So we can take that, and again, instead of simulating all the ports, that'll take a couple hours, we are going to select only the output nets of the power amplifier. And we're going to trace the output nets of the power amplifier through the redistribution technology, through the ball grid array, and then up into the filter. So we're including multiple different technologies on these two traces. And so this simulation is much more design friendly. You can run this simulation in 3 or 4 minutes as opposed to a couple of hours for the entire thing. So it gives you much faster feedback on the design process as you're developing the package. Now, one other thing you can do is we have a couple different circuit simulation technologies. So depending on the application, you can use either the FEM full 3D solver or the microwave solver. For this particular case, I'm going to use the FEM solver because there's a couple 3D components like bond wires in here, and I want to consider those in my analysis. And then I run the simulation that takes a few minutes, and you get results here, which shows S parameters. So I can look at, for example, all of the return loss of my traces. I can look at the isolation. But another thing that a lot of times designers want to do is take these results and integrate them back into their higher level circuit analysis. And the way you can do that in RF Pro is very simple. You can just generate test benches or sub-circuits. And so here I can generate a new sub-circuit for this design that includes the traces that I have. This is a much simpler 4-port simulation as opposed to my larger EM simulation. And then I can take this and drop it into my higher level circuit design. And so I can quickly analyze pieces of my design across different technologies very quickly, very efficiently, using our assembly and RF Pro technologies. If you want more information about circuit design using Pathwave, visit us at keysight.com. Thanks.